In this video, I'm going to go over some examples of problems where you will use the properties of parallelograms to solve for something. And in our first example, we are asked to find the missing angles. And you'll notice that the only angle labeled is the angle labeled S, which has a 64-degree angle. Now, obviously, this looks like an obtuse angle, and I've put a 64 here, and I probably should have put it over here. But we're just going to go with it because we can use the property the same way. And yes, in a realistic situation, it would probably be over here. But in this case, we'll say that this is 64, and if this angle is 64, one of the properties of parallelograms is that the opposite angles are congruent. So if the S is 64, the Q is also 64, if I can get it to right. And then we need to figure out the P and the R. And so we know that they're congruent because they are opposite of each other. One of the other properties of parallelograms that we're going to look at is that the adjacent angles are supplementary, meaning they're going to add up to 180. And the reason that is the case is because of these parallel lines. In parallel lines, if I continued this and continued this, looked at them that way, cut by a transversal, which this line at RS would be, these would be same-side interior angles, and same-side interior angles are supplementary. So either way that you want to look at it, the S angle and the R angle are going to add up to 180. So in that case, 180 minus 64 is what you're going to be thinking, and that gives you 116. So this angle would be 116, and again, since opposite angles are congruent, angle P would also be 116. Okay, and again, I do apologize for having the obtuse angles and the acute angles mixed up, but the properties are still the same. All right, so I have another one here, and this one I would like for you to try. This one is set up a little bit more realistic because the 86-degree angle is acute. But if you will take a minute and pause and try this one on your own. Okay, so the first thing that I would notice is that angle A and angle D are across from each other, and just like I said in the last problem, opposite angles are congruent in a parallelogram. So angle D would be 86 degrees as well. And then if I want to find angle B or angle C, I just have to look at it as being on the same side as angle D or angle A, and therefore it has to add up to 180. They're supplementary. So I'm going to do 180 minus 86, and that is going to give me 94. So I know that angle B is 94, and because they are across from each other, angle C is 94. So that is how we are going to use those opposite angles being congruent and the adjacent angles being supplementary. Okay, for our next example, we are going to use the property that opposite sides of a parallelogram are congruent to determine what x is. Now, I didn't mark all of the markings on this, so before I go on, I want to talk about what those would be again. A parallelogram has opposite sides parallel, and we use the little arrows to show that they're parallel. So I might use one arrow to show that these two are parallel, and two arrows to show that these two are parallel. And another marking for parallelograms is that the sides opposite each other are congruent. So if I mark this with one straight mark, I would have to mark this one with one straight mark. And then to denote that the other two might be a different length, I'm going to use 2 marks and 2 marks. So again, our opposite sides are parallel and our opposite sides are congruent. And it is that opposite sides being congruent that's going to allow me to set these two sides equal to each other to find x. So I'm going to say 2x minus 3, this one, is equal to x plus 2. And then it just becomes an equation to solve. So I'm going to subtract x. So 2x minus 1x is 1x. And then I'm going to add 3. And I'm going to get x to be 5. And in this case, it did ask us to find x. And so we have. They could have reworded the question and said, say, find AB, or the length of AB. And in that case, we would plug the 5 back in where the x is and have 5 plus 2, and we would answer 7. But that's not what they ask us in this case. I just want to get you to pay attention to exactly what the directions are so you don't miss an occasion like that. All right, and then for our last example, we have a parallelogram that has the diagonals labeled inside of it. And the property that we know about the diagonals of a parallelogram is that they bisect each other. So they cut each other in half. So I know that this piece is congruent to this piece, and this piece is congruent to this piece. So I can use that information to set up equations. If I do that first one, I know that the y will equal x plus 1. Well, that's not something I can just solve. So let's do the other one. I have that 3y minus 7 is equal to 2x when I put the two pieces that are equal to each other here. Now I have two equations. Both equations have x and y. And you've done stuff like this probably in a previous math course and where you used one of two things, either substitution or elimination. I'm going to use substitution this time because that y is already by itself. It's just going to make things easier. So I'm going to take this x plus 1 that is equal to this y, and I'm going to put it in for the y right here. Now when I do that, I want to make sure to put parentheses around it because it is multiplied by 3, which means I'm going to have to distribute. And if I don't put parentheses, I might forget to do distribution to the whole thing. So I'm going to replace this y with x plus 1. So I'm going to say 3 times x plus 1, and then I'm just going to continue writing everything else that was already there. So minus 7 equals 2x. Now, this is what I was talking about. I need to do 3 times x and 3 times 1 to distribute. So 3 times x is 3x, 3 times 1 is 3, and then I need to combine like terms. So on this side here, I have 3 and negative 7, or 3 minus 7, so I'm going to get minus 4. And then I have a couple different options here. I think I'll just subtract 3x. It'll give me a negative, but I'll work through that. So this will go away. I have negative 4 will equal negative x. And then I don't want it to be negative x, I want it to be positive x. So I'm going to divide by negative 1. 2 negatives will make a positive. And my x will equal 4. So that solves that out. Then I need to find y because our directions said to find x and y. I can plug this 4 into either one of my original two equations. I'm going to plug it into the one on the left because it just seemed easier. So y equals x plus 1. I know that x is 4, so y has to be 5. So I have x and y, and I've solved the problem. So that's just how you can work a few problems that deal with quadrilaterals and their properties of parallelograms.